Hey everyone, and welcome to This Explainer. I am absolutely thrilled you're here today because we're going to dive into the really fascinating, literally life-saving science behind preserving food right in your very own kitchen. There's just something deeply rewarding about taking fresh, seasonal produce and capturing it in a jar to enjoy months later. But getting it right? Well, that's not just about following your grandma's recipe. It is all about understanding microbiology and physics. So let's jump in and uncover the precise science of safe home canning. Okay, really quick, before we get to the fun stuff, I do need to pause for a very serious warning. The information in this explainer is definitely not a definitive guide. It's entirely possible that critical safety information has been omitted here. The rules of canning are absolute, so please treat this explainer strictly as a starting point for you, as a reasonable adult to conduct your own independent research. You always want to refer to tested, research-based guidelines, like those from the USDA, before you start canning. And honestly, this quote right here brilliantly illustrates exactly why we need that warning. Even a taste of food containing this toxin can be fatal. That's from the National Center for Home Food Preservation. And it really highlights the incredible stakes involved in home canning. We're not just trying to stop our peaches from getting mushy, right? We are actively preventing the growth of a deadly toxin. And the scariest part is that the danger lurking in an improperly processed, seemingly innocent jar is completely invisible, tasteless, and odorless. Section 1. The Villain. Clostridium botulinum. So, meet Clostridium botulinum. To really understand how these guys operate, it helps to think of them kind of like plant seeds. These bacteria exist out in the environment as totally dormant spores. They're on most fresh food surfaces, just surviving harmlessly in soil and water for years. Just like a dry seed sitting in a little packet, they don't do anything at all. But if you take that seed and plant it in the right environment, it wakes up. It grows into vegetative cells, multiplies like crazy, and produces that deadly botulism toxin in as little as 3 to 4 days. So you're probably wondering, what exactly is that perfect environment that wakes the spore up? Well, look at these conditions. First, a moist environment. Second, low-acid food. Third, temperatures sitting right between 40 and 120 degrees Fahrenheit. And finally, an environment with less than 2% oxygen. Do you see the terrifying irony here? When we put food into a jar, seal it tight, and pull all the oxygen out to preserve it, we are literally engineering the ultimate, perfect breeding ground for this deadly toxin. Because without oxygen, normal spoilage bacteria can't grow, which just completely clears the way for botulinum to thrive unnoticed. Section 2. The Arsenal. The pH divide and processing methods. But hey, don't panic. We've got the science and the tools to fight back. And if there is literally one single number you remember from this entire explainer, make it 4.6. This is the absolute critical dividing line on the pH scale. The pH scale measures acidity, and the lower the number, the more acidic the food is. Well, 4.6 is that magic threshold that dictates your entire battle plan. Here is exactly how that divide plays out. On one side, we've got low-acid foods. These are foods with a pH higher than 4.6. Think your meats, seafood, poultry, milk, and pretty much all fresh vegetables. Because they don't have that natural acidity, they have absolutely no defense against botulinum spores. But on the flip side, we have acidic foods, meaning a pH of 4.6 or lower. This is stuff like most fruits, pickles, and sauerkraut. That natural acid actually blocks the growth of the bacteria, or it destroys them super rapidly when heated. Oh, and a quick, really vital note here, some tomatoes and figs actually hover right above 4.6. So to process those safely as acidic foods, we actually have to add lemon juice or citric acid to push them safely below that line. All right, so how do we process these different types of foods? This table lays out our 3 main weapons. First up, for acidic foods, we can use a boiling water bath. This is where you just submerge the jars in 212-degree Fahrenheit water. Another great option for acidic foods, specifically those that need less than 45 minutes of processing, is atmospheric steam canning, which uses steam to hit that same temperature but with way less water. But look down at that bottom row. For low-acid foods, botulinum spores can easily survive 212 degrees. No sweat. So the only safe method is pressure canning. By putting those jars under pressure, we actually force the temperature way up to between 240 and 250 degrees Fahrenheit. That extreme heat is quite literally the only way to completely destroy the spores in an environment that lacks acid. Now, physics throw us a bit of a curveball depending on where you happen to live. Elevation totally matters. As you go higher above sea level, atmospheric pressure drops, which means water actually boils at a lower temperature. And as we just learned, a lower boiling temperature is far less effective at killing bacteria. So the crucial takeaway here is, if you live above 1,000 feet, you have to adjust your recipe. That means either adding more processing time for water baths or dialing up the pressure on your pressure canner to compensate. Section 3, the battle plan. Preparing your first jars. So here's your chronological progression for safe canning as a beginner. Step 1. Wash and sterilize your jars and really make sure to inspect them for any little cracks. Step 2, once they're filled with your food and liquid, grab a flat plastic spatula, not metal, actually, because metal can scratch and weaken the glass, and run it down the inside to release any trapped air bubbles. Moving on to step 3, carefully wipe the rim completely clean. Even a tiny speck of food can totally ruin the seal. Then apply your lid, and whatever you do, do not over-tighten the band. You just want to tighten it until you feel resistance. If it's too tight, the air inside can't vent out during processing, and your jars might actually buckle or break. Step 4, process and vent for the exact time required by your recipe. Step 5, take them out and let them sit at room temperature for 12 to 24 hours. Never try to force cool them. You want the natural contraction of that cooling process to pull the lid down and form a super high vacuum. And finally, step 6, test those seals by pressing right in the middle of the lid. If it clicks up and down, I've got bad news. It didn't seal. Section 4, the aftermath, safe storage and vigilance. Okay, let's say your jar is perfectly sealed. You might think the battle is totally over, right? Well, let's look at the proper storage rules, because how you store them is absolutely critical to safety and quality. Notice that first point, remove the screw bands. People leave them on all the time, but if you take them off, you actually prevent the bands from rusting onto the jar. And more importantly, if a seal fails while it's just sitting on the shelf, a tight band might temporarily hold a lid down, creating what we call a false seal that completely hides spoilage. Yikes. Next up, wash the outside of the seal jar to prevent any mold growth from sticky residue. Then store them in a clean, dark, dry place and try to maintain temperatures of 50 to 70 degrees. Anything over 100 degrees sharply increases the risk of spoilage. Make sure you consume them within 12 months, and if you have to stack them to save pantry space, never go higher than 2 layers. You really don't want to put undue pressure on those vital seals. Section 5, identifying and discarding spoilage. Even with the very best practices, sometimes a seal gets breached or a mistake is made. Here are the visual and olfactory warning signs you constantly need to look out for. When bacteria or yeast grow, they produce gas that pressurizes the jar, which leads to loose or bulging lids or liquid that aggressively spurts out the second you open it. You also want to look closely for any cloudy liquid, sediment, unnatural color changes, or unexplained bubbles moving up through the food. And keep an eye out for cotton-like mold, which, by the way, could be white, blue, black, or green, as well as any foul odors or slimy food. But please hear me loud and clear on this. Never, ever taste food that you suspect might be spoiled just to check if it's bad. Like we learned earlier, the botulinum toxin is deadly even in microscopic, completely invisible amounts. If you see any of these signs, discard the jar immediately following safety protocols. Well, we've covered a whole lot of ground today, right? From the incredible science of pH and pressure to the precise steps of creating a vacuum seal that locks out dangerous bacteria. Honestly, canning is such an empowering, wonderful skill when you do it with respect for the science. So I'm going to leave you with this final thought. What seasonal produce will you research and can first? I highly encourage you to go look up that definitive USDA complete guide to home canning, read up on your absolute favorite fruits or vegetables, and safely begin your own home preservation journey. Thanks so much for hanging out with me on this explainer, and happy, safe canning.